Can all of you see the question, all the 5 questions, right? You all can see the 5 questions. Someone just acknowledge that. I mean, in the peer deck thing.
Only question 1 is visible, sir.
You cannot see the other questions?
No, sir.
Okay. So can you just, I mean, there should be one arrow button, right, to move to the next slide. Is it not there? In the bottom left corner, most probably.
No, sir. I'm opening it in mobile. I'm not able to get it.
Okay. So is there someone who is opening it from computer?
Yes, there is a arrow button.
Yeah. Can you click on that and check whether the other questions are also visible or not?
Yes, I checked already.
Okay. Yeah. For those who are joining from mobile, I mean, you can just focus on the question which I will discuss currently. I mean, on the screen, right? And others, if you want to write something, I mean, before I go to those questions, the question 2, 3, 4, the other ones, so you can write your comments. But those who cannot see it, then you can just focus on what we are discussing at present, one by one. Okay, so my screen is visible, right? You can see the question 1 on my screen, correct? Is it visible? My screen is visible to you?
Yes, sir. It is visible.
Okay, thanks. Fine. So here we would not have options, so that's why I would want those who are commenting on the peer deck window, you have to write in your own words, in a sentence maybe, that what is this, I mean, the answer to the question. So in this question, we are asking that what could the variables count and final store, right? So you just have to write in peer deck in a sentence that what is count storing and what is final storing. Okay, so let's discuss the first question. I would wait for 2 minutes now, then up to 9:18, and then I would start discussion. So please go through the pseudocode. Okay, fine. So can someone wants to say anything regarding count? What would be there inside your count variable? This count variable. Okay, no one wants to volunteer, so fine. So let's see, let's proceed one by one. So L1 and L2 are two of our empty list initially, right? And then in this while loop, we are actually traversing the, the data set, the words data set, as it has been told over here, the words data set. And by traversing the words data set, we are reading the each word in X, right? In X we are given. And we know that how to add elements in a list. From your week 5 knowledge, you should know that if L1 is a list and I am adding the X dot word, that is the value, the word itself, as an element in the L1 list, right? So we are doing that in L1 list, we are adding the current word which we read. And after that, at line number 5, we come to an if statement which says the word ends with a full stop. So if the word ends with a full stop, so that means you are at the end of a sentence. So when that happens, then I would do some task. Okay, I'm not going into what is that right now, but let us see if we do not have this if statement satisfied. That is, line number 5 is not satisfied. In that scenario, what is happening? So I'm taking the first word into X, right, and then adding that word into a list L1. Okay, and then this if statement is not satisfied, so I would move the word to table 2 and proceed further. So again, I would read the second word into X and add that into the list L1. And let's say again this if statement did not satisfy, and I would move the word, move that word into the table 2 and proceed further. So basically, I would be adding all the words which I can find in the data set before I encounter a full stop. In which list? In list 1. So first time when it is iterating, it is getting all the words in a single sentence, right? In the first sentence. Okay. So fine. So after that, when it sees that there is a full stop, what it is doing is it is simply adding the contents of L1 list, which I have been gathering till now, right? Which I have been gathering till now. I am adding that into a L2 list. Now, what would be there inside the L1 list? That when I reach this if statement, that when it gets satisfied, what would be present inside the L1 list? So let's say if I have the words, right? Assume the words data set has these words consecutively. Let's say quick down. Okay, then there is a full stop, suppose. Okay, and then we have something like okay, and then there is again a full stop, and let's say like this we proceed. Okay, so what would be there in L1 initially? L1 I'm adding all the words till I get a full stop. So the first full stop I would get here. So all the words in a single sentence would be present inside the L1 list. As soon as this condition at line number 5 gets satisfied, I am adding the contents of L1 list into the L2 list. Right? L2 list was initially empty. So L1 would have, right, this whole thing, this whole complete all the words as each element. So first it would be the, right? Then the next element would be quick. Next element would be brown, according. Dot dot dot. Last element would be dog, full stop. This would be my L1 list. Then when the if condition satisfied, I would make L2 list equal to the initial L2 was empty. So after that, I would add L1 as a member of L2. So see, L1 is itself a list, right? This list. And then I'm adding L1 as a component in L2 list, right? This is the meaning of adding a component. So L2, and inside this I would have the L1 list. Dot 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 up to dog. Fine. And at this moment, when I at first initialize L2 with L1, I add the L1 into L2 and then I make L1 empty. And then I again proceed. So what is this line of code up to from line number 1 to line number 10? This part of the code, what it is basically doing is extracting out every sentence from the words dataset, and by extracting each sentence, it is adding each sentence as a separate component, as a separate list into the L2 list. So this code is extracting every sentence from the words dataset, and it keeps each sentence in a new list and add each of those new lists into the L2 list. Okay, so at the end of the execution of the lines from 1 to 10, I would get a list of all the sentences that I have in my words dataset. So the next would be hello, how, dot, 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 all. Again, whatever, let's say I have some other sentence, so I would get something like this. So this is L2. So this is your list of list. So this week starts with the list of list concept. This is your list of list. And after that, what I am doing at line number 11. Okay. So initially I have initialized a variable with count equal to 0. And then we are iterating over the L2 list over here. Right. Now L2 is this list. We have written it over here. So I'm iterating over L2. So can someone tell me that when I write for each x in L2, what would be the first value of x?
So the first sentence,
Okay, so can you just tell me very specifically what should I write? X equal to? Correct, the first sentence, but can you tell me how should I write it?
sir, in the list,
Yeah, so
open the
I,
bracket.
yeah, thanks.
Yeah.
So quick dot. So this is X. I mean the first X. For each X in L2 means the first X. So initially X is this value, exactly this list. So we know if X is a list, I can use the length function with a list, right? And also I can use the init function with a list. So in the next line, I can use the init of X. So when I write init of X, what does it mean? What would be the output? Let's say I apply init of X over here, right? What would be the output? What does it
Sir,
mean? Yeah,
remove the last,
correct. So I
the
would,
dog you have to remove, and
yeah,
then the rest of the sentence.
exactly. So dot 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 dog is removed. So whatever, let's say whatever word was there before dog, that would be the last sentence. Okay, so lazy. Lazy would be the last word. Fine. So this is my new list, right? Init of X. Now init of X is done. After that I have length, right? So again I have to apply length. So what we are doing is we are applying length on this whole thing. Right? So now we are checking that whether the length of this new list which we got, if that is equal to 9, then we are increasing the count. So if that is equal to 9, what does it mean? I mean, what it tells you about X, the original X that we had. So you removed init, one word, the last word from X by using init, right? So that was your 10th word. I mean, assuming that this condition is becoming true, that means now you have 9 words in the list. So that means initially you had 10 words in the list. Correct? Initially you had 10 words in the listing, and in manner, if you had 10 words in the list, that essentially means you had 10 words in the first sentence. Right? So count is incremented whenever the sentence that I'm getting, right? That sentence has 10 words. Or you can directly write, so when I ask what is count story, the answer is number of sentences which has 10 words. Okay, any doubt up to this point? Fine. Okay, so what are we doing next? So next thing is we say max equal to 0. As soon as you see max equal to 0, that means you are trying to find some maximum thing, right? So let's check what are we doing now. So I see I'm running another the same kind of loop for each y in L2. Now we already know L2 is this thing, so each y would be, this is one y, the next iteration y would be this, the next iteration y would be this. I mean the whole list would be y, correct? So for each y in L2, I have another variable here called count2 equal to 0, okay? And then I have for each x in y. Now this is a bit complex kind of structure, not very difficult, but see, when I'm writing for each y in L2, what would be y in the initial first iteration? It would be equal to this, like same like x only, the quick dot dot dot. This would be value of y in the initial first iteration. And at that time count is equal to 0, count 2. Fine. And then I'm writing for each x in y. Now you see we are using in y. We know y is a list. So you can use in a list, right? So that means x is basically the words, right? X is basically the words inside that list. Now for each x in y2, sorry, in y, what we are doing is we are incrementing the count plus 1. Count 2 plus 1, basically. So that means what? We are basically counting the number of words present inside each sentence, because y is nothing but sentences, right? Sentences implemented as a list. Implemented in a list. Okay. And x is what? Each of the sentences. So this is basically a list of sentences. Y is a list of sentences. Sorry. This is a sentences. So basically implemented in a list. And x is basically your word. Word in the sentence, which is basically y. Okay. So y is a sentence like this we discussed, and x is each word within that sentence. Now we are increasing that. That means essentially we are counting the number of words in each sentence. And if that count is greater than max, then we are modifying the max by that count, and then we are putting final equal to y. So what is y? Well, we have already discussed that y is nothing but the sentence. And here you are checking the count is what? Number of words. Number of words in y. Okay, so if the number of words in y is more, then I am allocating a max variable, and I am accordingly making final equal to y. So when I ask the question that what would final store at the end of execution, right? The answer should be that it is storing the, can someone tell what should be the answer? Is storing the sentence with maximum number of words. Okay. So count is storing the number of sentences which has 10 words, and finally storing the number of sentences which has the maximum number of words. Is it clear? Is there any doubt? Okay. Fine. So let's proceed. Right. So this is the second question. And here basically we have learned about insertion sort, right, in this week. How do we do insertion sort and all. So this is basically testing that whether you know how to do insertion sort. So we want to sort this list by applying insertion sort. In how many iterations of the sorting process? You know that insertion sort takes a loop to complete, right? So it runs the loop on each element, and then it accordingly inserts the element at a proper position, and then replaces the old list with a new list. That was the main way how insertion sort was working. So taking each element and placing it in its correct position within the list, right? That's how insertion sort works. Now we would actually see the answer to this question by performing simple insertion sort. And in some scenarios, you would see that you need not actually whatever change, whatever number that you are getting, that number you need not insert it any other place. It is already placed in its correct position. So that means basically you do not have to make any changes in the list, right? As soon as I mean in the subsequent iteration. So we have to count how many such iterations are possible in the given list, right? So let us see how we can do that. Let me just check the responses if there are any. Okay, fine. So let's do this. So how does insertion sort works? I would write it as steps. So step 1. So first number is, we would start from 90, right? We would start from 90 and then I would compare 32 and 90. Right? I would compare 32 and 90 and we would see that whether what is the correct position for 32 and 90. So initially, let me write step 0, not step 1. So initial state of the list. If any one of you have any doubt, please tell in between only. Huh? So 32, 16. Fine. So this is my step 0. I did not do anything. Now we are starting step 1. The first iteration of insertion sort. So I would start from 90 and I would check whether 90 is compared to 32, that whether 90 is more than 32 or less. I'm sorting in ascending order. So I would check whether 90 is before 32 or not. And I see that no, 90 is greater than 32. So I need not make any change. So I keep it as it is. 32 is smaller, so it remains in front. And all other elements remain as it is because this is our first iteration. So I would only check the first element, which is 90. Right now, in the second iteration, now we would compare with 69. Right. So let's see. So 32, and then see we have 69, but 69 is lesser than 90 and greater than 32. So correct position of 69 is here, and then we would have 90, and all other elements remain same. So we are comparing from 69, right? So we have not yet reached whatever is after that. We would reach the next number, which is 97, and all other subsequent number in the next in iterations. So do not confuse that why we are writing the same things again, right? Because you have your algorithm, your insertion sort program, pseudocode has only worked from up to 69 at the current iteration. So 72, 84, 23, 101. Now I would be a bit fast. So 32. So which number I would take now? We did till 69, right? So 97 is the next number. And you see that 90 and 97 is already, I mean, this part is already in the correct sequence. So even though I encounter a new number 97, but I do not have to do anything. So let's write it as it is. Because up to 90, it is in its correct position. 97 is greater than 90, and that's why it is after 90. So it was already correctly placed. Step 4. So which number is the next number? 72, right? Now we see that now 72's correct position is after 69. So we place 72 here. And then 90 and then 97. And everything else remains as it is. From 84, we have not started, so it remains same. Okay, great. Next is step 5. Okay, so which number is the next number? 84. On 84, we would check, right? 84 should come here actually. And 23 and 101 are untouched. Okay, we have not touched them. Okay, sorry. So the next number is 84 was done, so we would do for 23 now. Now 23 is the smallest one, so obviously it would come in the first place, and then we would have all other numbers. And finally 101. So step 7. Now again see 101 is already in its correct position. Right here we started comparing 101, but the thing is 101 is already placed in its correct position. We did not make any change. So now we have 7 steps, right? From 1 to 7. We completed our sorting. Why? Because we have ended, right? So 101 was the last element to be worked upon. After that, the list has ended. So now see that when which cases we did not make any change in the intermediate lists. So like if you see from step 0 to step 1, we did not make any change. It remains as it is, right? So this is my one count. In step 1 to 2, we made changes, right? 69 came forward, 90. So there is a change. From step 2 to 3, no, right? Step 2 to 3 is one for another scenario. So 32, 69, 90, 97, 32, 69, 90, 97, then 72, 84, 23, and 101. So again, there is no change. Similarly, here again we have changed. So 72, 90, 97, there are changes, right? So this is not a scenario. And here also we have changed 90 and 84. Again, between 5 and 6, we have 5 and 6 also we have a change, 69 and 32, right? And 6 and 7, yeah, 6 and 7, we do not have any change. So 3 possible cases. So your answer is, in how many iterations of the sorting process does the list state remains unchanged? So your answer would be in 3 steps. Okay, simple insertion sort. If you know how it is working, then you should be able to answer it. Any doubt in this? No doubt? Okay, great. And by the way, in the last session, we have discussed the insertion sort code. So if any one of you have doubt in the insertion sort code, so please revisit the last session. Okay, so the next question is question number 3. And now we are, let us pay some attention over here. As in the last session, some of you were asking that how to reverse a list and some related questions like that. So we are trying to do some exercise on that here. Okay, so that is quite a hint to all of you if you want to solve it. So okay, I would wait for maybe 2 minutes. So 44 is already. So I would wait for 46 up to 9:46, and then we would discuss this. Just check the pseudocode once and try to understand what it is doing.
Hello.
Yeah.
So the T2 is not initialized first time.
Huh?
T2 list
Okay.
T2 is not initialized with the
Okay.
empty
Okay.
set.
Yeah. You
Empty
can
list.
assume that. Got it. Got it. Yeah. You can assume that it is there. I mean,
Okay.
initially it is empty. Just assume that T2 is there inside.
Okay.
Or maybe here or any place.
Okay. So then the answer will be T2 will be having the list of list T1. That
T2
means
would
the
have
number
it.
of words. T2 will be having the number of
Okay.
words stored in T1.
But
Number
in
of
reverse
words.
order.
Number of words stored in T1. That's concern now. Someone else was also telling. So what's your answer?
Sir, it will store the sentences in the reverse order.
Okay, so just correct me if I am wrong. So let's say I have sentences like not meaningful sentences, just example, the box, hello. So let's say this is one sentence. Then I have, let's say, India is a nation. And then I have, let's say, dog. Let's say we have these three sentences. These are the full stops. Okay, and then what should be T2? Can you tell me? How should I write T2? First of all, it is a list that we all know.
Yeah,
Now,
it's a
after that,
list. Sir, the 1 minute.
okay,
This is for sure that it will give the reverse order.
okay. So, what reverse? Should I write something like this? That boy, cat, dog,
Dog.
something like this, or how should I write it?
Yeah,
Or
this
is it,
is correct.
or is it something like this? Hello,
Yeah,
box. I mean, this another answer.
the
Box, then the, right? And then maybe let's say this is one list. Have let's say nation. So accordingly, the last one. And so is it like this or is it like this?
sir, the bottom one.
Great. So this one, right?
Yeah.
Someone else has any opinion? Or I mean, neither of them is another option, huh? None of the above. Those, that is
Sir,
also correct. Yeah,
T2 will be having the list of words in T1, I think, in the form of
that's
list.
it. That's it, right? So T2 would have the number of I mean the words which are there in T1, correct?
Yes, sir.
So maybe something like this. You mean that as it is. So this is one list. Dot, dot, dot. Another list and then dot that. Right? Okay. So now let's see. We have 2, 3 possible answers. Let's see what's happening actually.
1 minute, sir.
Huh?
The hello box. The I think the first one should be boy,
First one.
cat, dog.
This one, right?
Yeah.
Oh, nice. So let's see.
Yes, sir. First two.
First one. Right. Okay. See, let's do what happens. So everything, all the fun is happening between these two lines. And all the other things that we have already discussed. So this is up till this line. Up, line 1 to 10 is the same code which we learned in the last question, last to last question, which was basically nothing but you are storing all the words which are present in the words data set on the basis of sentences. So all the words in a sentence, you are adding that in a list and that list is L1. And when you are adding all the words in a given sentence and you encounter a full stop, then you add all the words within that sentence as a separate list into L2. So L2 is basically a list of list, and with all the words with all the sentences in it. Now after that, from line 11, the new thing starts. So let's see what is X. So whenever we are writing X first for each X in L2, L2 was something like this thing, right? I mean, this like this. L2 was writing this because it's important. No? Box hello. Second element was function. And by the way, these are all separated by comma because these are also list. Okay, and this is also separated by comma because that's the element of the outer list. Finally, doc direct call. So this is your L2. Okay, now let's see. For each X in L2, when I'm writing each X in L2, what does X signify? X mean? X means the whole thing, this whole list, each of these lists, right? So initially X, then T1 is null. Then I see for each Y in X. Now X is this internal list. In the first iteration, it is this list, the first one, right? And then I'm going for X inside, for Y inside X. So that means now I'm iterating inside this list, only inside these three words, right? So what would I have in T1 then? Let us see. At first I'm adding the word, the first Y in X, right? So Y would be this. Y would be the. So initially I would add the, and my T1 was empty, so it would be just empty, right? Empty list. T1 is anyway empty in the first iteration, and this Y would be the. Okay, so we get the list T1 is equal to the. After that, what happens? I'm again running the loop. So I come over here again, and then I go to Y in X. So the Y proceeds further on box, right? And that's why, what do I do again? Y comes at first. So Y is box. So essentially this statement changes to be box over here. Initially the list was the, right? So I'm appending, let's say, on the left hand side. So basically this changes. Okay. Box and the, and after that what happens? Accordingly, I would add the hello, and by the same logic you would see hello would come over here. Okay, so if I complete the whole thing, what would it look like? Fine, so this is my T1. After the for loop finishes at this point. After that, what we are doing, we are making T2 equal to T1 plus T2. So, okay, so T2 was initially empty. Let's do that. T2 was initially empty, and then I'm adding this list, right? T1 as the list I'm adding. So this is line number 12, 16, I mean. What would it happen? T2 equal to T1. So what is T1? T1 is already this hello box, right? This is itself a list, and we are adding it, right? With what? We are adding it with T2. Now T2 is an empty list. So essentially, this was boiled down to what? T2 is a list of list with the hello box and the. As of now, it has one element. Now again, I come to the next for each iteration over here, and I see X in L2. So let's go for where we actually stopped over here, right? So first X was this. So now my X is the next one, which is this is my X. Next iteration for X. And accordingly, we saw that this T1 essentially was reversing the first, the words of the first list. So accordingly, here what would be the scenario? It would reverse the word likewise, and T1 would become, by similar logic, nation, and A is India. Right? Something like this, nation. So this is T1, and after that I would come at T2, and then what I am doing, T1 plus T2. So T1 has been appended on left hand side. So initially my T2 is this thing, right? So now I am appending on the left hand side. So that means what? My final list, the list of list T2 would look like this is being appended, T1 is being appended, the current T1, right? This T1 is being appended on the left hand side. And the previous element, that thing was hello. Oh. Right? So this is my T2 after the second iteration of the for each loop. Accordingly, we would go to the third iteration, which is dog cat boy, and now you can guess that again dog cat boy would be reversed and also it would be added in front. Right? So the correct answer is which one? The first one. Right? Boy, cat, dog, and then nation A is India, and then hello box. So here we actually did reversal twice. If I would have stopped at the inner loop, right, in the loop which from line number 13, 14, and 15, not 13, 14, and 15, then we would have reversed each sentence. But again, due to line number 16, we are reversing it one more time. I mean, effectively making the, we are making it appended in front, and that's why it looks we have also reversed it the whole paragraph, right? So we have first reversed within the line, within the sentence, right, by reversing each internal list in the for each loop, and then again we are reversing the whole thing, the whole paragraph or the whole data set of word by again adding the sublist or the sentences in another, in the reverse order. So sentence is also in reverse order and the word inside the sentence is also in reverse order. So now the whole thing is totally in reverse order, right? So that's why T2's this answer is the correct option. As the first choice. These all are wrong. So this was regarding how you can reverse, right? If you simply have to reverse, you can just write this for loop and that's it. It would be reversed within the sentences. Okay. Any doubt? Anyone has any doubt in this? Fine. Now this is a bit not complicated, but a bit involved code. Now we would learn a nice thing over here. Easy thing only, but I think we have yet not seen a construct like this. Now you would have seen things like x dot marks or physics marks or whatever, or let's say x dot put anything else. Let's say I don't know, maybe name. Right. So we knew that what is this, or let's say if I would have deleted this one. Right, some other value, let's say some other y dot marks. Right. Some dot dot dot. So what is this? This is basically a list of pairs. So we have learned about list of pairs. We have learned about list of triples, right? So this is kind of a list of pair. But now in this week we are learning about list of list, which we have seen in the previous examples. Now this code, it is a bit interesting thing. So you see what is this over here. So you see that now in the general example that we saw for pairs, both of them were some kind of numbers, some numeric value. But here the pair itself has a list inside it. So L1 is a list. What is L1 doing and all those things we would come, but L1 is a list and count is a number. And this is acting like a pair and that is being added into the L2 list. Right? So essentially this is a structure like this. Comma, let's say alpha. I'm using some value alpha, beta, gamma for the numeric values. You can assume the alpha, beta, and gamma would be the numeric values. So I would have a pair like this. So this is my pair 1. Comma, the second pair. Now the pair itself has a list and one numeric value. It's pair 2. Right, dot 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 like this. I have the list is empty. So this is again a nested list, but here in this scenario, the nested list of I mean the pairs, the one of the element inside the pair is a list itself. That's the only point of complexity in this code, right? And let us discuss now what it is. So I would wait for, let's say, 2 to 2.5 minutes, and then we would discuss. Okay, so fine, let's discuss it now. Someone wants to say anything? No volunteers? Okay. Fine. So now at first, let us look at the code on the right hand side. So what is this this procedure insert? What is it doing? So if you have gone through the lectures, I think this piece of code should be quite easily understandable to you, or at least you should be able to recognize that the same kind of code, not same kind, actually the same code, little bit difference is there. We have sir has actually taught that it's exactly the same code. So this is basically your insertion sort. I mean, not insertion sort in that respect. I mean, it's the insert function. So the way insertion sort works, right? The main thing is the insert function. You are calling the insert function multiple times, right? So that is what is happening from line number 17 to line number 31 in the procedure insert. Okay, so I would discuss that, but let us see before that what is happening in line number 1 to 60. Okay, so let's see. So we have what are we doing? Initially we had two empty lists L1 and L2, and we had a count which is initialized to be 0. And then we are reading the words like we were doing earlier and adding it into a list. The only difference is now we are making a count and we are increasing the count, right? So what is it actually doing? It is the count is being increased every time we are reading a word, and then when we are actually experiencing a full stop, that means we have reached the end of a sentence, right? Then what we are doing? So at this point, I mean before line number 7, right? Before line number 7, what would I have in count and what would I have in L1? L1 is just the same thing. L1 would have all the words of the current sentence, and count would have the number of words in that sentence, right? So initially we counted the number of words using a for each loop, but here we need not do that. When we are calculating the, when we are reading the sentence, then only we are actually finding that how many words are there inside that sentence. Okay, so I have count storing the number of words in the current sentence, and L1 would have all the words within the current sentence. Okay, so now we are reaching the end of a sentence at line number 6, the if statement. And when it reaches the end, what are we doing? We are making L2 plus L1 count. So this structure I already explained to all of you that how it is happening. L1 is itself the list. So if I take my previous example, so if I have, let's say, uh, let's say the boy is one sentence, then I have, let's say, okay, second sentence, and let's say I have a third sentence. Okay, fine. So if these are the sentences, then what would my L2 look like at this stage? I mean, when the whole first part is over, we are essentially doing the same thing, but only in the previous code we were adding L1 into L2. Now we are adding L1 plus a count value as a pair in L2. So L2 would look like this. So this is my L2, a pair, right? So at first I would have this pair thing, but inside the pair I have the list itself. L1 is a list itself, right? So let us draw a list. Right? The first list would be, right, the boy. Right, this is one element of the pair. The other element of the pair is the number of words within the sentence, right? So 2. So this is my pair. So this is my pair 1. Okay, now let's draw the whole thing. Accordingly, my next element within the L2 list would be Again, the next word, which is India is my nation. I'm not writing the whole thing. India is dot dot dot. Okay. And then the number of words, right? So 1, 2, 3, and 4. So this is my pair, right? So pair 2. And accordingly, I would have the third pair. I'm not writing that. Right? Here I would have the pair 3 and then my loop would end. I mean, sorry, the L2 list would end. Okay. So fine. So what are the things that we learned till now? L2 at line number 12 is essentially this kind of a structure which comprises of a list of pairs. It is a list of pairs, and each pair, the first element is a list itself, and that list is basically the sentence, right? Each sentence. And the second element of the pair is the number of words within that sentence, right? Something like this. So this is the structure of your L2. Okay. Now what we are doing, let's see, we have an empty list paragraph at line number 13, and then we are iterating through for each I in L2. Now that is, when I say I in L2, right? When I say I in L2, what would be the first I? I would be the whole pair, right? Because L2 is the list of your these elements, right? Of these pairs. So when I say I in L2, that means the pair, the first pair, the whole pair itself. So this thing is I in my first iteration. Okay. Then I come to paragraph equal to insert of I in paragraph. So this I in the first iteration that I know, how does it look like? It is this thing. Fine. So I is this thing in my first iteration, and paragraph is nothing but an empty list. Okay. Now let's come in the insert function. Now this is basically the same insert function. What we are doing over here is we have an empty list, right? This list we would use to create the modified list. So the sorted list, right? The sorted list would be the temp list. I would create the temp list by depending upon this if condition. So let us see what we are doing. We have an inserted variable which we are initializing to false, and then we are actually traversing through all the element in the para. Now what is para? Para, we are passing the paragraph, right? At first. So paragraph would be empty. So para would be empty in the first iteration. And what would be y? Y we are passing I, which is this element in the first iteration. Okay. So we check for each z in para, but para is empty in the first iteration. So there is no element. So I directly come out of this loop at line number 27. Right. And I check if not inserted, which is true because my inserted is false. Right. And because that was the initialization value of inserted, right? So false and not of false would be true. So this statement is being executed. Line number 28 would be executed. So temp is in empty list at this point. So we are making temp equal to temp plus y. Now what is this y? Y is what we are passing this I, right? I was being passed inside one. So y is nothing but this is your y. Right? So that means what? We are again adding this, right? This pair which we got, this pair is being added inside the temp list. Fine. So what would temp look after the first iteration? Temp would look something like this. Okay, so this is my temp after the first iteration. And then I return temp, right? So temping is returned out. So temp would be now put inside paragraph. So paragraph becomes temp now. Okay, so paragraph is also equal to this. So both temp equal to paragraph equal to temp equal to this thing. Okay. Now we are doing that again and again for all the subsequent pairs in L2, right? So next iteration I would become this pair, and in the third iteration I would become the pair corresponding to hello friends. So I would do the same step. What we are doing is now let's come back to the insert function again, and this time my y is my pair 2, the second pair, and what para is no more empty list, it is this element, right? Para is now this tick. So let's proceed. Okay. So again, inserted is false for z in para. Yeah. So now I have a value in para, which is my, you can see this para, this para, right? So the boy, this first pair, this pair 1 is there in my para. So z is equal to the pair 1 in the first iteration. And what I am checking is now if last of y. Now what is y? Y is my pair 2. So this is my pair 2. Okay. So what would be the last of pair 2? What is pair 2? By the way, pair 2 is nothing but a list. Now last is the second value of the list, right? Because in a pair we have only the first and last. So 4 is my last of y in that sense, right? So I'm checking whether 4 is less than equal to last of y means 4. So whether 4 is less than equal to last of z. Now what is z? Z is in para. What is para? Para is this thing, right? I mean this list, paragraph or para, same thing. We are passing the paragraph inside para equal to 10. So the boy comma 2, this first pair is in your para, and you check the last of that. So what is the last of this pair? What would be the last of this pair? Last of this pair would be what? Would be 2, the second element. So I'm checking whether 4 is less than equal to 2 or not. Okay, so and I see that no, and obviously not inserted is this holds because inserted we have not inserted the current y, which is my pair 2. So inserted would anyway remain this false, and false not of false would be true, right? So but this condition doesn't hold. 4 is not less than 2, and that's why what we are doing is we are actually moving out of this if condition to line number 25. So in line number 25, what we are doing, we are simply appending the current Z, that is the new element that I got, right? The pair 2 element. So that pair, that thing I'm appending, okay, inside the list. So we would do that. So basically that means you are inserting all the elements pair by pair on the basis of their in the decreasing order of their count, because that's what we are doing. Last of y is the count of words. So when I ask you the question, what is the value of what does paragraph stores at the end of the execution of this whole program? So what it would store? It would simply store the sorted sequence of pairs in which the first element would be the sentence and the second element would be the count of number of words in that sentence, and the order in which it is being sorted, that order is on the basis of the number of words within that sentence. Okay, number of words within that sentence. Okay, fine. So any doubt till now?
Sir,
Yeah.
sir, henceforth, are we not going to get some options?
So I replaced the option actually this time so that you can directly write. Some options give you hint without actually testing the whole pseudocode completely. So when we release these questions, then I would add the options. But in this discussion session, I intentionally removed the options. Okay.
But in the exams?
Exams you would get, obviously, yeah. Exams you would get options.
Okay.
So you have the practice on graded questions, right? So like that only the exams would happen. Okay. So I just go through the insertion sort pseudocode once. I hope you would be able to answer all these things. So if I come down to the next question, this is basically a continuation of my first question. So let us again write over here the sentences that we had. The boy, India is my mission. So the boy was my Fine. So what did you understand in the previous code, that after the everything ends, my loop was so let's actually add one more letter over here so that both of them do not remain two, and the boy runs, so that I have all the different counts to represent it properly. Okay, so if these are the sentences that I have on which it runs, assuming these are the sentences on which my previous pseudocode runs, so I am getting the paragraph sorted on the basis of the count of the number of words. So I see the number of words here is 2, here it is 4, and here it is 3. Correct? So my pair, how should my paragraph look like? I would have the first pair inside paragraph as the hello friends. Fine, and the count was 2. So this is my pair 1. Okay. So this is my pair 1. And then my pair 2 would be the next available, the next minimum count, which is 3. Right? So the sentence corresponding to that is the boy runs. And count is 3. So this is my second pair. And my final pair would be the last one, which is so what we are doing is basically the previous pseudocode, as I have explained, is basically sorting it on the basis of number of words within the sentence and adding that into the in a list of pairs format in paragraph. So here I have 4 is the number of words. So that's my final pair, and then my paragraph ends. So the previous pseudocode would actually, from this, assuming this is your words data set, it would actually make something like this. Okay. Now you can just directly apply the logic and answer the question. So what is the output for init of paragraph? Can someone tell?
So the first one?
First one means, can you tell me how should I write it? What should I write?
So the first two sentences. The
First.
boy runs.
Okay.
India is my nation.
Okay, so in the form of list, how should I write it? Can you tell me?
So in this 3 also there.
Yeah.
I mean the count is also writing.
Okay. So in it, what it would do, it would actually remove the last one and have all other components, right? So I'm applying that on paragraph. Now, what are the elements inside paragraph? If I tell you to mark the element, so this is one element, right? This whole thing is one element inside paragraph. This is my second element.
Okay, this paragraph. Okay,
yeah,
okay.
so that's the idea. So
the
whenever
last one I have to remove.
correct.
So hello
whenever,
friends.
Yeah, just a second. So this is very important. Whenever we are applying init or first or whatever, the only trick in those kind of question is you have to identify which are the elements, right? That's why I asked which elements are, I mean, what are the elements of the list? I am applying on the list, but what are the elements? So you actually have to find out what is the boundary of the element. You can have a complex structure like this, a list of lists within a pair or a triple or something like that. So like this, right? So you identify the element. So this is one whole element, this is one whole element, and this is my third element. These are 3 pairs which are put inside the list, and this is the outer boundary of the, let me use the black color. This is my outer boundary. Okay. So now let's see what should be the answer now. If these three are the elements, so I write init. So it would remove the last element. So this element would be removed and all other things would be there. So the result would be something like hello friends, and then the value 2 and the pair closes, and then I would have the next pair, which is the boy runs and then 3 and the pair closes, and then the list also closes. So the first two elements I would have in the input. Okay. Now what should be the answer for the second one now?
Hello, friends.
Yeah. Hello. So what would be the first of paragraph? First of paragraph would be this whole element, right? This whole element. This whole element, that is the pair, would be your first of paragraph, only this part. And then inside this pair again, since this pair is also a list, right? So inside this pair, I am again using first, right? So now what would be the case? If this is the element I am considering, on this I am applying the first. So I have two
It would be
elements.
hello, sir.
Yeah.
Hello only.
It would be hello. Okay, so let's break it down. So
Sir, just a question. The
yeah,
hello friends and two, those are the entire thing, right? So in it would be hello friends. And under that, if we take first, so we are taking the first element of hello and friends in that element, right?
can you tell me what is this thing? If I write first of paragraph, what would I get?
So first of paragraph would be the first element, right?
Which element? What do you mean by element?
The hello friends, that part.
This will I get two?
Two is it? I can't see if two is inside or not.
Okay.
Uh,
So this is your pair, this whole thing. So I mean, this data structure we created just in the previous user code, right? So you
Yes,
would
sir.
have the list of the sentence in the form of a list,
Mhm.
the count of the words, and these two would form the pair. So this is a pair. This whole thing is a pair. Okay.
Mhm.
And
Yes, sir.
inside the pair,
Then two would be inside since it's a pair.
exactly. So when I write first of paragraph, that means the whole thing. Hello friends, with two, it's with two also, right? The whole thing.
Yes, sir. Yeah.
Okay. Okay. And then again I do first. So what does that mean?
So only the hello friends, that
Exactly.
part would be included.
So the list,
Yeah, that
right?
list. Yeah.
So what is the format of my pair? So if I come to the pseudocode again here, so this was actually the format, right? This the sentence, the number of word were making the pair one, pair two. Now the list of such pair was paragraph. Okay, so if you see this part of
Yes.
the code, so I have an integer value over here, which is the count, and I have a list over here. And this list is nothing but the sentence. And this int is nothing but the number of words. Okay, and this whole thing is added in the list, so we would have a list of such pairs. Pair 1, pair 2, not this thing. And each of these pair is of format like this, right? So now let's come to the over here and let's see what's happening. So first of paragraph is this whole thing, the blue mark thing. So I mean, if I highlight it, it would be this whole thing. So this whole thing would be what? First of paragraph. Okay. Now if I tell that again, if I do a first, so corresponding to this first, right? So what would happen? So within the list that I have painted in yellow color. So then I'm again doing first, so I would get the first element, which is this element. this element, which is the list, right? Because the last element is the second one, which is the numeric value 2. So hello friends is the answer. I mean the list. So you should write it in this format. I mean, when in the exam you would have options. So let's see if I ask you, these two options are there. Hello friends is one option. Hello is another option. And let's say third option is hello friends. Okay, and there is some fourth option. So you have to think which option is the correct. So this should be your correct answer.
Yeah, with the braces, right?
With the braces, because that's first means whenever we are doing first, last, or whatever, that is we are doing on the element. Now, if this whole yellow painted color is my is the first paragraph, right? The result of this whole thing. I'm replacing this whole thing with the yellow painted color thing. On that yellow painted data structure, I am calling first. Now, this yellow painted things first is the first element. So this first element is the list itself. So I should answer it with the list. I mean, this is the list.
In the list format.
In the list form, correct. So the answer for that is hello. Okay, so that's your answer. Now, if I go further, is the following statement, right? This statement which you can see over here, is this true or not?
True.
Not true.
Not true. Okay.
5 is not equal to 1.
Okay, now actually now I have changed the. Wait, just a second. Let me check. I just changed the data set, right? Okay, so let's solve. Let's see what happens. So let's start from the right hand side because it looks smaller. So I do first of paragraph. So what would be first of paragraph? Let me delete these colors. Okay. Fine. So what would be my first of paragraph? The same thing, right? This whole thing. With the whole pair, the first pair. So this is my first of paragraph. And then I'm solving this part, the right hand side. So first of paragraph is this green color. Marking with color now. So the green color thing is first of paragraph. Now again I do last. Okay, on this. So when I do last, what do I get?
So the integer value, the 2, the count over there.
So I would get 2. The integer value. So last is this integer value 2. So my answer is 2 minus 1 is equal to 1. Okay, now let's come to the left hand side. Okay, so let's see first of paragraph, same thing, nothing different. This whole yellow part, and then again first, which is basically this part, the list, right? First of paragraph is the yellow part, whole thing, and then again first, which is the list itself. Okay, and then init. Now, what do we mean by init? We are reducing. I mean, we are considering all the element of the list on which I am making init, other than the last element. So remove the last element. So the result of this up to init, what would be the result if I tell you to? So this would
So
be
hello, sir. Till hello, only hello.
only help, but in the list.
Yeah, list formation. Yeah, list formation.
Yeah.
Sorry.
So that's my answer. And then I have length. Now, what is the length of hello? That's 1. The
5,
length
sir.
of this. Okay, so now the thing is,
Double 5, yeah.
correct, but there is one problem. So that's the understanding thing. So when I am writing length of, what is this over here? I have hello as one element, right? And then I had another element as friend, right? And I have removed one element from I mean, from this list. So this was my whole list. So let's call this list. Let me call it. Let's say L1. Okay, that was my list, and on that I was calling length. So if on this I would have called length, what would I get in the answer?
Yeah, the length is 1.
I would get 2, right? So that's why this is a very tricky thing. So again,
So
pay
it's
attention
true.
over here. Yeah, yeah. So it's equal to true. On this, if I have hello and friend, right? So I would answer that, okay, length is 2. I have 2 elements. But what would init do when I write init with this same thing, hello and friend? Friend. It would remove one of the element and it would create the list hello. Now the thing is, hello is an element inside the same list. I am not creating a separate hello character by character, right? That means I am saying this list is not equal to this is different, right? I had 2 elements over here, hello and friend. I removed the last element. So I would have only one element, which is hello. But hello is an element, whole element over here. It's not a list of characters. A list of character is this thing. So if I would have applied length on this list, then I would have got 5, right? But here only
Oh yeah, okay. Yeah. Now I got it. It's just actually if the element is there, the length is actually calculating the number of elements in that list, isn't it?
Yeah, exactly. Yeah,
Okay, got it.
exactly. Fine.
Okay.
So once init removes the last friend thing, so I have only one element. So that's the tricky part. When you see something like this, only one word is here. So don't think length would give you the number of letters in this word. This is just a singleton list. Singleton means there is only one element in that list. So the length on that list would give you 1, right?
So sir, basically we need to keep this in mind. Doesn't matter if like what kind of list is that. We need to keep this in mind that length of a list would be the number of elements in that particular
Exactly.
list. Doesn't matter
Exactly.
what's in there.
Yeah, exactly.
Okay, got it.
And throughout this whole, I mean, whatever this complex kind of list of triple list of whatever we complex things we did, I don't think we had any practice question like this where we had one list of pairs, and as a pair you had a list inside that pair. None of the practice questions or graded question. I don't think that there are any such example. Most of the example you would have some numerical value within the pair, right? Or let's say one numerical value, one string value, something like that. But the thing is, even if I would have increased one more level of complexity in this, and I would have again nested one more list, you don't have to worry. Only thing you should identify properly is what are the elements at each level. So when I'm talking about the outer list, so when I'm, let's say in this example, when I'm talking about this bracket, right, this pair of bracket, black ones, what are the elements with respect to this pair of bracket? I mean, this list, the paragraph list. So then you identify that the elements are pairs. So the elements of paragraph list are pairs, right? All these pairs. So that is your step 1. Now you would go inside, okay, now I got the pair. So if this is my pair is the element of paragraph list, now I would check what is the element of pair. So pair is again a list, right? This list. So pair is again a list. So I would check what are the elements of pair. So elements of pair are 2 things. This is the first element of pair and this is the second element of pair. And then I see, okay, second element of pair is a number, that's fine. But first element of pair is a list again. So as long as you get some list, right, you would list or your triple or double or what I mean pair, you would go on. So now I would get another list. Now again, if this is a list now, there is another last level of nestedness. Now I would check what is the element with respect to this list. And now I find that, okay, hello is the first element with respect to this list. And friend is the second element with respect to this list. And that's where my nesting ends. So if you can carefully find out at each of the levels that what is the element of the list at that level, then your this last first or whatever init, whatever kind of code, even you need to find out that because if you have to write pseudocodes which are a bit complex like this, right? Not very complex, this is not that much complex, but let's say, yeah, it's a little bit more complex than the examples that we discuss in practice, I mean, your graded questions. So if you have to write pseudocode to answer those kind of questions, you have to actually identify only one thing, and that is what are my elements at each level of the list. If you can identify that, your work is done, right? So I mean, some tricky situations are examples like this. So if I write that, what is the element of this list? What is, or let's say R, I don't give you the hint, but is or are the elements over here? Then you can say, okay, H is an element, E is an element, L is an element, L is an element, O is an element, which is a wrong answer. The answer is there is only one element, which is hello, right? And my answer would have been H is an element, E is an element, if I would have got something like this. That's it. If you can identify that, then your work is done. Fine. So here we got hello was 1, and here we did 2 minus 1, 1. So this is definitely a true statement. Okay. Now can you answer what would be this last one, and then we would end this.
Is it 5?
Okay, great. So let's do that. So first of paragraph, what would this part give me? Let me delete this. Fine. So first of paragraph, again the same thing. Hello friends. Then 2. This is my first of paragraph. Fine. So what would first of paragraph give me? Right till here. The first on this, so I would get the list.
The hello friend.
Fine. And then again one first.
So only hello this time.
Okay, but inside list.
Yeah, list format. And length of this is 1, since we are only collecting the, calculating the elements in that list. So it will be 1.
So it should be 1. The same thing that we did in the previous example. By the way, is it correct? I just followed along with your answer. Did we do some mistake?
The first of the paragraph means the entire thing, and then
Sir,
first means hello friend.
Sir, I think hello should not be in a list.
See,
Yeah, we had a mistake. We made a mistake actually.
I again repeated the same
Yeah, we made a mistake.
so that you will just follow along. See, be very careful. That's why after explaining all this again, I did the same thing. See, so when you are doing, I would repeat why it's happening. First is, when I'm doing first, I'm getting the list itself. Okay, done. Then again, I'm doing first, but first on this list, right? Right? So what is the, I mean, what are the element at this level? The element is hello and friend. Element is not hello and friend. This is not my element. Is this my, are these two my elements over here? No, right? And my elements are only hello word and friend word. And that is, the whole thing is inside list. So let me just, yeah. So you see over here, this, on this I'm applying first, right? On this I'm applying first. What is the list over here? The list is hello and friend. Okay. So my question is, what are the elements? Whenever you feel confused, just ask yourself this question: what are my elements? So the elements are hello and first. Sorry, friend. Whatever you call it, friend. Okay. So these two are my elements. This is my first element. This is my second element. Fine. So, if you can, if you again see in terms of what we did in the previous scenario. So when I had this thing, right? When I had this thing, my first bracket was here, and then I had the list as my first element. So did I say that this list? So when I write first on this, right? Let me just erase this. So when I say I'm writing first on right, when I'm saying this, okay, so on which list I'm applying first? On this one. Okay, so my question is, what are my elements? So when I say what are my elements, my first element is this thing, and my second element is this thing. So if I have to write the first element is the list, that is fine. But am I saying that my second element is something like this? No, right? Second element is 2, and that's it. First element is a list in its own being, that's why it is a list. Accordingly, when I write first on this list, so hello is not a list on its own. Hello is a word which is present inside the list, right? Like 2 was a number which is present inside the list. So I got 2 as the second, not 2, not this, direct 2, because that's my second element. So likewise, hello is my first element, friend is my next element, and that's why my answer over here is first on this would return hello. Okay, and not friend. I mean, not in list. And on that, when you apply len, this is just a string. There you fit. Fine. Be very careful with these things when you write, and even this carefulness is important in order to write pseudocode. We don't have a subjective evaluation here, but at least to understand the pseudocode properly, you have to know all this. Fine. Okay, so we did a little bit of difficult example in this session, but I think most of your practice questions and graded question would be easier than this. So, but just try to make sense of all the examples that we discussed. If you already understood all the things, then great. If there is a little bit of doubts, then please practice with similar example and try to do what happens. Try to check what happens. Okay. Fine. So if there are no more doubts, we would stop the session, or else you can ask.
Sir?
Yeah.
Sir, is this session recorded, sir?
Yeah, it's recorded.
Oh, okay, sir.
It would be there on the YouTube.
So there is no link, I mean, provided to, I mean, in the calendar.
On the calendar, there is no link that would be updated, but I think in this meeting, a link was given. Let me check the chat.
Will you please provide the link, sir? If
Yeah, you can check the chat. It's there in the chat.
Sir, in chat is
The
blank,
link
sir.
will be
Oh,
in the
okay, okay.
Google Calendar.
I hope now everyone got it, right?
Sir, link will be in the Google Calendar live YouTube link.
Google Calendar, I think the link has not been updated yet. Let me check. But anyways, I have given the link in your in the chat. Just check the chat.
So I have a doubt. Can I ask?
Yeah. Yeah.
In the activity question 6.5,
Okay, just a minute. Let me check the calendar once. Activity question 6. Okay. In the chat. Just check the chat. Yeah, in the Google Calendar, I don't think the YouTube link is there. So whatever link I pasted in the chat, you can check that. The link would be.
in the activity question 6.5,
Yeah. Just a minute. Check the calendar once. Activity question 6. Just a second. Activity question 6.5. Which question? I don't think the YouTube
fourth,
link is
the
there.
last
So whatever link I pasted in the chat, you can check that. So, yeah, I think someone is playing the YouTube video. I would ask you to please mute it. Okay. Yeah, activity question 6.5. Which question?
oh, the last one, fourth one.
Okay.
I'm getting the answer 100, and I don't know how it is 1 of 1.
So you are getting the answer. Okay, let me share.
So today in doubt session, sir clear this doubt.
I was not there.
I'm telling it anyways. So, what is the total number of words present in the paragraph, right? Now you are getting the answer as 100, correct?
Yeah.
Okay, fine. So let us see what we are doing. So what is it doing? It is taking the VV, VC, CV and CC. There are 4 categories, and each category is storing that words which start with a vowel and followed by a word which start with a vowel. And in other categories, I would have a word which is starting with a consonant or following and followed by a vowel, or starting with a vowel followed by a consonant. But the point to be noted here is that all these 4 categories, I have this condition as common, followed by a word, followed by a word, followed by a word, followed by a word. So all the words that are being segregated in these 4 categories must have been followed by one word. If it is a consonant, then I would put it either in these 2 categories, I mean this BC or CC. If it is a vowel, I would put it in VV or this CV or VV category. But the concept is at least by one of the word in all of these 4 category, I should have a word that is following it. But what happens for the last word in the sentence, I mean in the whole data set or your paragraph? The last word is such a word which would not be in any of these 4 categories. Why? Because the last word is the terminating word. There would be no word which is following the last word. So I cannot say that in case of last word, if you check, followed by a word, this is false. Followed by a word. There are no words after the last word. So followed by a word, followed by a word. So all these 4 things fails. So whatever word that you are getting, that would be all the words except the last word. So if I sum this up, I would have 100, and I mean, I would have total 100 words, and the last word would be 101. Does that make
Okay.
sense?
Thank you. I got it.
Sure. Okay. Thanks all. Thanks for attending the session. Good night and happy Diwali.
Good night,
in
sir.
advance.
Good night, sir. Thank you so much.
Yeah.
Thank you, sir.
Right, sir.